All right. So this is example two. But in this example, we're gonna go over the guidelines of choosing U and DV. Now the book. Now what I've been using is this acronym, right? LIATE. That's what I've been using. Okay. Now the book doesn't really use that, so I'm gonna kind of go with the book. What this acronym helps me. What is it helping me do? Why follow this acronym, or why? How does following this acronym help me set up or find or choose my U and DV? Okay, let me say that one more time. How in the world does this acronym help me choose U and DV? Right? Because I just went in order, correct? U is going to be the first one, the first part, and DV is going to be the second part. Okay, whatever comes in order in that little acronym. Okay, the way it works is this. Usually DV, our DV, our derivative, is usually the most complicated problem or the most complicated portion, okay? So usually DV is the most complicated portion. And then U is the remaining factors, okay? That's usually what happens, okay? So we pick our DV to be the most complicated portion and U to be the remaining factors. Or another way of looking at it is the U is the portion whose derivative is a function simpler than U. Okay, now we're out of the room. Than U. All right. So usually those are the guidelines when you're trying to determine V and DV. So number one, DV can be the most complicated portion, okay, of the integrand, or U is and use the remaining factors, or U is the portion whose derivative is a function simpler than U, okay, and DV is the remaining factors. So, and I mean, that's why, and again, that's why I go by this. This helps me a lot because this takes care of these guidelines, okay, when I go by that acronym. So let's look at the next example here. So the next example says, okay, now I'm going to use that acronym, LIATE, right? So let's see what I have here. Well, A squared is algebraic. Ln x is the log function. Well, which one comes first in the acronym? Well, the log comes first before the algebraic. So therefore, because the log comes first before the algebraic in this acronym, the log is going to be my U and A is going to be my DV. Okay. And so we start setting up our formula. U du v dv. So which one's going to be my U? Well, the L, the natural log, right? So ln of x. Let me kind of write it in a different color here. Okay, ln of x. And dv, well, that's my x squared. Okay, I forgot my x for the ln of x. So the natural log of x is my u. Okay, so then what's my du? What's the derivative of the natural log of x? Well, the derivative of natural log of x is 1 over x dx. Okay, and what's v? Well, to find v, you have to take the integral of dv. Well, the integral of x squared is x to the cube over 3. Okay, so then now we set up our integral. So to find x squared natural log of dx, we're going to go the integral of x squared natural log of x dx is equal to u times v. So it's going to be natural log of x times x cubed over 3 minus the integral of v times du. X cubed over 3 times 1 over x dx. See, that's how simple it is to set it up, okay? Once you find your u and your dv, then that's how you set it up. That's simple. All right. So now we're just going to clean this up a little bit before we take the integral. Now, so I want to go the integral of x squared natural log of x dx is equal to, well, natural log of x times x cubed over 3. I'm just going to rewrite it like this, class, okay? I'm just going to write it as 1/3 x cubed natural log of x. I didn't do anything. I just rewrote it in a different way, okay? Just rewrote it in a simpler form. Didn't do any math at all, right? Minus, now here we go. Now, to take the integral of this x cubed over 3, hey, I noticed that one of these x's here can cancel out with this x here. So if it cancels out with this x here and cancels out one of these x here's, what am I left with? I'm left with an x squared over 3 times 1. Okay? All right? So that means I have the integral. Okay? I'm just going to rewrite it like this. Instead of saying x squared over 3 times 1, I'm just going to say 1/3 times x squared dx. Okay? And now I'm ready to go, right? So the only thing I got to focus on now is this integral. So I can do that integral without integration by parts, right? What's the integral of 1/3 x squared? I'm just going to do this step by step. Well, it's going to be the integral x squared natural log of x dx is equal to 1/3 x cubed natural log of x. Well, this 1/3 can come out, right? Minus 1/3. And I can take the integral of this x squared all by itself, right? So therefore, the integral of this x squared is just going to be x to the 3 over 3, right? And I'm done, plus c. And so we know that 1/3 times this 1/3 here is going to be 1/9. So my final answer is going to be the integral of x squared natural log of x dx is equal to 1/3 x cubed times the natural log of x minus 1/9 plus c. So therefore, I found the integral of x squared. So the integral of x squared times the natural log of x dx is equal to that. This is my answer. Okay, so that's example 2.